Chapter 6 of Organic Gardener's Composting. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betsy Bush in Marquette, Michigan, December 2008. Organic Gardener's Composting by Steve Solomon. Chapter 6 Vermicomposting. It was 1952, and Mr. Campbell had a worm bin. The shallow box, about 2 feet wide by 4 feet long, resided under a work table in the tiny storeroom greenhouse adjacent to our grade school science class. It was full of what looked like black, crumbly soil and zillions of small, red, wiggly worms, not at all like the huge night crawlers I used to snatch from the lawn after dark to take fishing the next morning. Mr. Campbell's worms were fed used coffee grounds. The worms in turn were fed to salamanders, to Mr. Campbell's favorite fish, a 14-inch long smallmouth bass named Carl, to various snakes, and to turtles living in aquariums around the classroom. From time to time the soil in the box was fed to his lush potted plants. Mr. Campbell was vermicomposting. This being before the age of ecology and recycling, he probably just thought of it as raising live food to sustain his educational menagerie. Though I never had reason to raise worms before, preparing to write this book perked my interest in every possible method of composting. Not comfortable writing about something I had not done, I built a small worm box, obtained a pound or so of brandling worms, made bedding, added worms, and began feeding the contents of my kitchen compost bucket to the box. To my secret surprise, vermicomposting works just as Mary Applehoff's book, Worms Eat My Garbage, said it would. Worm composting is amazingly easy. Although I admit there was a short learning curve and a few brief spells of sour odors that went away as soon as I stopped overfeeding the worms, I also discovered that my slapdash homemade box had to have a drip catching pan underneath it. A friend of mine, who has run her own in-the-house home box for years, tells me that diluting these occasional insignificant and almost odorless dark-colored liquid emissions with several parts water makes them into excellent fertilizer for houseplants or garden. It quickly became clear to me that composting with worms conveniently solves several recycling glitches. How does a northern homeowner process kitchen garbage in the winter when the ground and compost pile are frozen and there's no other vegetation to mix in? And can an apartment dweller without any other kind of organic waste except garbage and perhaps newspaper recycle these at home? The solution to both situations is vermicomposting. Worm castings, the end product of vermicomposting, are truly the finest compost you could make or buy. Compared to the volume of kitchen waste that will go into a worm box, the amount of castings you end up with will be small, though potent. Apartment dwellers could use worm castings to raise magnificent houseplants or scatter surplus casts under the ornamentals or atop the lawn around their buildings or in the local park. In this chapter, I encourage you to at least try worm composting. I also answer the questions that people ask the most about using worms to recycle kitchen garbage. As the ever-enthusiastic Mary Applehoff said, "I hope it convinces you that you too can vermicompost, and that this simple process with the funny name is a lot easier to do than you thought. After all, if worms eat my garbage, they will eat yours too." Locating the worms. The species of worm used for vermicomposting has a number of common names: redworms, red wigglers, manure worms, or brandling worms. Redworms are healthy and active as long as they are kept above freezing and below 85 degrees. Even if the air temperature gets above 85 degrees, their moist bedding will be cooled by evaporation as long as air circulation is adequate. They are most active and will consume the most waste between 55 to 77 degrees, room temperatures. Redworms need to live in a moist environment, but must breathe air through their skins. Keeping their bedding damp is rarely the problem. Preventing it from becoming waterlogged and airless can be a difficulty. In the South or along the Pacific coast, where things never freeze solid, worms may be kept outside in a shallow shaded pit, as long as the spot does not become flooded, or in a box in the garage or patio. In the north, worms are kept in a container that may be located anywhere with good ventilation and temperatures that stay above freezing but do not get too hot. Good spots for a worm box are under the kitchen sink, in the utility room, or in the basement. The kitchen, being the source of the worm's food, is the most convenient, except for the danger of temporary odors. If you have one, a basement may be the best location because it is out of the way. While you are learning to manage your worms, there may be occasional short-term odor problems or fruit flies. These won't be nearly as objectionable if the box is below the house. Then, too, a vermicomposter can only exist in a complex ecology of soil animals. A few of these may exit the box and be harmlessly found about the kitchen. Ultra-fastidious housekeepers may find this objectionable. Basements also tend to maintain a cooler temperature in summer. However, it is less convenient to take the compost bucket down to the basement every few days. Containers. Redworms need to breathe oxygen, but in deep containers, bedding can pack down and become airless, temporarily preventing the worms from eating the bottom material. This might not be so serious because you will stir up the box from time to time when adding new food. But anaerobic decomposition smells bad. If aerobic conditions are maintained, the odor from a worm box is very slight and not particularly objectionable. I notice the box's odor only when I am adding new garbage and get my nose up close while stirring the material. A shallow box will be better aerated because it exposes much more surface area. Worm bins should be from 8 to 12 inches deep. I constructed my own box out of some old plywood. A top is not needed because the worms will not crawl out. In fact, when worm composting is done outdoors in shallow pits, few redworms exit the bottom by entering the soil because there is little there for them to eat. Because airflow is vital, numerous holes between 1/4 and 1/2 inch diameter should be made in the bottom, and the box must have small legs or cleats about 1/2 or 3/4 of an inch thick to hold it up enough to let air flow beneath. Having a drip catcher, a large cookie tray works well, is essential. Worms can also be kept in plastic containers, like dishpans, with holes punched in the bottom. As this book is being written, one mail-order garden supply company even sells a tidy-looking 19-inch by 24-inch by about 12-inch deep green plastic vermicomposting bin with drip pan, lid, and an initial supply of worms and bedding. If worm composting becomes more popular, others will follow suit. Unless you are very strong, do not compost a box larger than 2 by 4 feet because they will need to be lifted from time to time. Wooden boxes should last 3 or 4 years. If built of plywood, use an exterior grade to prevent delamination. It is not advisable to make containers from rot-resistant redwood or cedar because the natural oils that prevent rotting also may be toxic to worms. Sealed with polyurethane, epoxy, or other non-toxic waterproofing material, worm boxes should last quite a bit longer. How big a box or how many boxes do you need? Each cubic foot of worm box can process about 1 pound of kitchen garbage each week. Naturally, some weeks more garbage will go into the box than others. The worms will adjust to such changes. You can estimate box size by a weekly average amount of garbage over a 3-month time span. My own home garden supplied kitchen feeds 2 vegetable-eatarian adults. Being year-round gardeners, our kitchen discards a lot of trimmings that would never leave a supermarket, and we throw out as old salad greens that are still fresher than most people buy in the store. I'd say our 2.5-gallon compost bucket is dumped twice a week in winter and 3 times in summer. From May through September, while the garden is on, a single 2 foot by 4 foot by 12 inch tall, 8 cubic foot box is not enough for us. Bedding. Bedding is a high C/N material that holds moisture, provides an aerobic medium worms can exist in, and allows you to bury the garbage in the box. The best beddings are also light and airy, helping to maintain aerobic conditions. Bedding must not be toxic to worms because they'll eventually eat it. Bedding starts out dry and must be first soaked in water and then squeezed out until it is merely very damp. Several ordinary materials make fine bedding. You may use a single material bedding or may come to prefer mixtures. If you have a power shredder, you can grind corrugated cardboard boxes. Handling ground-up cardboard indoors may be a little dusty until you moisten it. Shredded cardboard is sold in bulk as insulation, but this material has been treated with a fire retardant that is toxic. Gasoline-powered shredders can also grind up cereal straw or spoiled grass hay if it is dry and brittle. Alfalfa hay will decompose too rapidly. Similarly, shredded newsprint makes fine bedding. The ink is not toxic, being made from carbon black and oil. By tearing with the grain, entire newspaper sections can rapidly be ripped into inch-wide shreds by hand. Other shredded paper may be available from banks, offices, or universities that may dispose of documents. Ground-up leaves make terrific bedding. Here, a power shredder is not necessary. An ordinary lawnmower is capable of chopping and bagging large volumes of dry leaves in short order. These may be prepared once a year and stored dry in plastic garbage bags until needed. A few 30-gallon bags will handle your vermicomposting for an entire year. However, dry leaves may be a little slower than other materials to rehydrate. Peat moss is widely used as bedding by commercial worm growers. It is very acid and contains other substances harmful to worms that are first removed by soaking the moss for a few hours and then hand squeezing the soggy moss until it is damp. Then a little lime is added to adjust the pH. Soil. Redworms are heat-tolerant litter dwellers that find little to eat in soil. Mixing large quantities of soil into worm bedding makes a very heavy box. However, the digestive system of worms grinds food using soil particles as the abrasive grit, in the same way birds chew in their crop. A big handful of added soil will improve a worm box. A couple of tablespoons of powdered agricultural lime does the same thing while adding additional calcium to nourish the worms. Redworms. The scientific name of the species used in vermicomposting is Eisenia fotida. They may be purchased by mail from breeders, from bait stores, and these days even from mail-order garden supply companies. Redworms may also be collected from compost and manure piles after they have heated and are cooling. Night crawlers and common garden worms play a very important part in the creation and maintenance of soil fertility, but these species are soil dwellers that require cool conditions. They cannot survive in a shallow worm box at room temperatures. Redworms are capable of very rapid reproduction at room temperatures in a worm box. They lay eggs encased in a lemon-shaped cocoon about the size of a grain of rice from which baby worms will hatch. The cocoons start out pearly white, but as the baby worms develop over a 3-week period, the eggs change color to yellow, then light brown, and finally are reddish when the babies are ready to hatch. Normally, 2 or 3 worms emerge from a cocoon. Hatchlings are whitish and semi-transparent and about 1/2 inch long. It would take about 150,000 hatchlings to weigh 1 pound. A redworm hatchling will grow at an explosive rate and reach sexual maturity in 4 to 6 weeks. Once it begins breeding, a redworm makes 2 to 3 cocoons a week for 6 months to a year. Or, one breeding worm can make about 100 babies in 6 months, and the babies are breeding about 3 months after the first eggs are laid. Though this reproduction rate is not the equal of yeast, capable of doubling every 20 minutes, still, a several hundred-fold increase every 6 months is amazingly fast. When vermicomposting, the worm population increase is limited by available food and space, and by the worm's own waste products or casts. Worm casts are slightly toxic to worms. When a new box starts out with fresh bedding, it contains no casts. As time goes on, the bedding is gradually broken down by cellulose-eating microorganisms whose decay products are consumed by the worms, and the box gradually fills with casts. As the proportion of casts increases, reproduction slows, and mature worms begin to die. However, you will almost never see a dead worm in a worm box because their high-protein bodies are rapidly decomposed. You will quickly recognize worm casts. Once the bedding has been consumed and the box contains only worms, worm casts, and fresh garbage, it is necessary to empty the casts, replace the bedding, and start the cycle over. How to do this will be explained in a moment. But first, how many worms will you need to begin vermicomposting? You could start with a few dozen redworms. Patiently begin by feeding them tiny quantities of garbage, and in 6 months to a year have a box full. However, you'll almost certainly want to begin with a system that can consume all or most of your kitchen garbage right away. So for starters, you'll need to obtain 2 pounds of worms for each pound of garbage you'll put into the box each day. Suppose in an average week your kitchen compost bucket takes in 7 pounds of waste, or about 1 gallon. That averages 1 pound per day. You'll need about 2 pounds of worms. You'll also need a box that holds 6 or 7 cubic feet, or about 2 by 3 feet by 12 inches deep. Each pound of worms needs 3 or 4 cubic feet of bedding. A better way to estimate box size is to figure that 1 cubic foot of worm bin can digest about 1 pound of kitchen waste a week without going anaerobic and smelling bad. Red worms are small, and consequently worm growers sell them by the pound. There are about 1,000 mature breeders to the pound of young redworms. Bait dealers prefer to sell only the largest sizes, or their customers complain. Red wigglers from a bait store may only count 600 to the pound. Worm raisers will sell pit run that costs much less. This is a mix of worms of all sizes and ages. Often the largest sizes will have already been separated out for sale as fish bait. That's perfectly okay. Since hatchlings run 150,000 to the pound and mature worms count about 600 to 700, the population of a pound of pit run may vary greatly. A reasonable pit run estimate is 2,000 to the pound. Actually, it doesn't matter what the number is. It is their weight that determines how much they'll eat. Red worms eat slightly more than their weight in food every day. If that is so, why did I recommend first starting vermicomposting with 2 pounds of worms for every pound of garbage? Because the worms you'll buy will not be used to living in the kind of bedding you'll give them, nor adjusted to the mix of garbage you'll feed them. Initially, there may be some losses. After a few weeks, the surviving worms will have adjusted. Most people have little tolerance for outright failure, but if they have a record of successes behind them, minor glitches won't stop them. So it is vital to start with enough worms. The only time vermicomposting becomes odoriferous is when the worms are fed too much. If they quickly eat all the food that they are given, the system runs remarkably smoothly and makes no offense. Please keep that in mind, since there may well be some short-lived problems until you learn to gauge their intake. Setting up a worm box. Red worms need a damp but not soggy environment with a moisture content more or less 75% by weight. But bedding material starts out very dry. So weigh the bedding and then add 3 times that weight of water. The rule to remember here is a pint's a pound the world's round, or 1 gallon of water weighs about 8 pounds. As a gauge, it takes 1 to 1.5 pounds of dry bedding for each cubic foot of box. Preparing bedding material can be a messy job. The best container is probably an empty garbage can, though in a pinch it can be done in a kitchen sink or a couple of 5-gallon plastic buckets. Cautiously put half the, probably dusty, bedding in the mixing container. Add about 1/2 the needed water and mix thoroughly. Then add 2 handfuls of soil, the rest of the bedding, and the balance of the water. Continue mixing until all the water has been absorbed. Then spread the material evenly through your empty worm box. If you've measured correctly, no water should leak out the bottom vent holes, and the bedding should not drip when a handful is squeezed moderately hard. Then add the worms. Spread your red worms over the surface of the bedding. They'll burrow under the surface to avoid the light, and in a few minutes will be gone. Then add garbage. When you do this the first time, I suggest that you spread the garbage over the entire surface and mix it in using a 3-tined hand cultivator. This is the best tool to work the box with because the rounded points won't cut worms. Then cover the box. Mary Applehoff suggests using a black plastic sheet slightly smaller than the inside diameter of the container. Black material keeps out light and allows the worms to be active right on the surface. You may find that a plastic covering retains too much moisture and overly restricts airflow. When I covered my worm box with plastic, it dripped too much. But then most of what I feed the worms is fresh vegetable material that runs 80 to 90% water. Other households may feed drier materials like stale bread and leftovers. I found that on our diet it is better to keep the box in a dimly lit place and to use a single sheet of newspaper folded to the inside dimension of the box as a loose cover that encourages aeration, somewhat reduces light on the surface, and lessens moisture loss, yet does not completely stop it. Feeding the worms. Red worms will thrive on any kind of vegetable waste you create while preparing food. Here's a partial list to consider. Potato peelings, citrus rinds, the outer leaves of lettuce and cabbage, spinach stems, cabbage and cauliflower cores, celery butts, plate scrapings, spoiled food like old baked beans, moldy cheese and other leftovers, tea bags, eggshells, juicer pulp. The worm's absolute favorite seems to be used coffee grounds, though these can ferment and make a sour smell. Drip coffee lovers can put the filters in too. This extra paper merely supplements the bedding. Large pieces of vegetable matter can take a long time to be digested. Before tossing cabbage or cauliflower cores or celery butts into the compost bucket, cut them up into finer chunks or thin slices. It is not necessary to grind the garbage. Everything will break down eventually. Putting meat products into a worm box may be a mistake. The odors from decaying meat can be foul, and it has been known to attract mice and rats. Small quantities cut up finely and well dispersed will digest neatly. Bones are slow to decompose in a worm box. If you spread the worm casts as compost, it may not look attractive, containing whitened, picked clean bones. Chicken bones are soft and may disappear during vermicomposting. If you could grind bones before sending them to the worm bin, they would make valuable additions to your compost. Avoid putting non-biodegradable items like plastic bottle caps, rubber bands, aluminum foil, and glass into the worm box. Do not let your cat use the worm bin as a litter box. The odor of cat urine would soon become intolerable, while the urine is so high in nitrogen that it might kill some worms. Most seriously, cat manure can transmit the cysts of a protozoan disease organism called Toxoplasma gondii, although most cats do not carry the disease. These parasites may also be harbored in adult humans without them feeling any ill effects. However, transmitted from mother to developing fetus, Toxoplasma gondii can cause brain damage. You are going to handle the contents of your worm bin and don't want to have a chance of being infected with these parasites. Most people use some sort of plastic jar, recycled half-gallon yogurt tub, empty waxed paper milk carton, or similar thing to hold kitchen garbage. Odors develop when anaerobic decomposition begins. If the holding tub is getting high, don't cover it, feed it to the worms. It is neater to add garbage in spots rather than mixing it throughout the bin. When feeding garbage into the worm bin, lift the cover, pull back the bedding with a 3-tine hand cultivator, and make a hole about the size of your garbage container. Dump the waste into that hole and cover it with an inch or so of bedding. The whole operation only takes a few minutes. A few days later, the kitchen compost bucket will again be ready. Make and fill another hole adjacent to the first. Methodically go around the box this way. By the time you get back to the first spot, the garbage will have become unrecognizable. The spot will seem to contain mostly worm casts and bedding, and will not give off strongly unpleasant odors when disturbed. Seasonal overloads. On festive occasions, holidays, and during canning season, it is easy to overload the digestive capacity of a worm bin. The problem will correct itself without doing anything, but you may not be willing to live with anaerobic odors for a week or two. One simple way to accelerate the healing of an anaerobic box is to fluff it up with your hand cultivator. Vegetable-eatarian households greatly increase the amount of organic waste they generate during summer. So do people who can or freeze when the garden is on. One vermicomposting solution to this seasonal overload is to start up a second summertime-only outdoor worm bin in the garage or other shaded location. Appelhoff suggests an old leaky galvanized wash tub for this purpose. The tub gets a few inches of fresh bedding and then is inoculated with a gallon of working vermicompost from the original bin. Extra garbage goes in all summer. Mary says, I have used for a worm bin annex an old leaky galvanized wash tub kept outside near the garage. During canning season, the grape pulp, corn cobs, corn husks, bean cuttings, and other fall harvest residues went into the container. It got soggy when it rained, and the worms got huge from all the food and moisture. We brought it inside at about the time of the first frost. The worms kept working the material until there was no food left. After 6 or 8 months, the only identifiable remains were a few corn cobs, squash seeds, tomato skins, and some undecomposed corn husks. The rest was an excellent batch of worm castings, and a very few hardy, undernourished worms. Vacations. Going away from home for a few weeks is not a problem. The worms will simply continue eating the garbage left in the bin. Eventually, their food supply will decline enough that the population will drop. This will remedy itself as soon as you begin feeding the bin again. If a month or more is going to pass without adding food, or if the house will be unheated during the winter sabbatical, you should give your worms to a friend to care for. Fruit flies. Fruit flies can, on occasion, be a very annoying problem if you keep the worm bins in your house. They will not be present all the time, nor in every house at any time, but when they are present, they are a nuisance. Fruit flies aren't unsanitary. They don't bite or seek out people to bother. They seek out overripe fruit and fruit pulp. Usually, fruit flies will hover around a food source that interests them. In high summer, we have accepted having a few share our kitchen, along with the enormous spread of ripe and ripening tomatoes atop the kitchen counter. When we're making fresh V7 juice on demand throughout the day, they tend to congregate over the juicer's discharge pail that holds a mixture of vegetable pulps. If your worm bin contains these types of materials, fruit flies may find it attractive. Appelhof suggests sucking them up with a vacuum cleaner hose if their numbers become annoying. Fruit flies are a good reason for those of Teutonic tidiness to vermiculture in the basement or outside the house if possible. Maintenance. After a new bin has been running for a few weeks, you'll see the bedding becoming darker and will spot individual worm casts. Even though food is steadily added, the bedding will gradually vanish. Extensive decomposition of the bedding by other small soil animals and microorganisms begins to be significant. As worm casts become a large proportion of the bin, conditions deteriorate for the worms. Eventually, the worms suffer and their number and activity begins to drop off. Differences in bedding, temperature, moisture, and the composition of your kitchen's garbage will control how long it takes, but eventually you must separate the worms from their castings and put them into fresh bedding. If you're using vermicomposting year-round, it probably will be necessary to regenerate the box about once every 4 months. There are a number of methods for separating redworms from their castings. Hand sorting works well after a worm box has first been allowed to run down a bit. The worms are not fed until almost all their food has been consumed and they are living in nearly pure castings. Then lay out a thick sheet of plastic at least 4 feet square on the ground, floor, or on a table and dump the contents of the worm box on it. Make 6 to 9 cone-shaped piles. You'll see worms all over. If you're working inside, make sure there is bright light in the room. The worms will move into the center of each pile. Wait 5 minutes or so and then delicately scrape off the surface of each conical heap, one after another. By the time you finish with the last pile, the worms will have retreated further and you can begin with the first heap again. You repeat this procedure, gradually scraping away casts until there is not much left of the conical heaps. In a surprisingly short time, the worms will all be squirming in the center of a small pile of castings. There is no need to completely separate the worms from all the castings. You can now gather up the worms and place them in fresh bedding to start anew without further inconvenience for another 4 months. Use the vermicompost on houseplants, in the garden, or save it for later. Hand sorting is particularly useful if you want to send a few pounds of redworms to a friend. Dividing the box is another simpler method. You simply remove about 2/3 of the box's contents and spread it on the garden. Then refill the box with fresh bedding and distribute the remaining worms, castings, and food still in the box. Plenty of worms and egg cocoons will remain to populate the box. The worms that you dumped on the garden will probably not survive there. A better method of dividing a box prevents wasting so many worms. All of the box's contents are pushed to one side, leaving 1/3 to 1/2 of the box empty. New bedding and fresh food are put on the new side. No food is given to the old side for a month or so. By that time virtually all the worms will have migrated to the new side. Then the old side may be emptied and refilled with fresh bedding. People in the north may want to use a worm box primarily in winter when their composting methods are inconvenient or impossible. In this case, start feeding the bin heavily from fall through spring, and then let it run without much new food until midsummer. By that time there will be only a few worms left alive in a box of castings. The worms may then be separated from their castings, the box recharged with bedding, and the remaining worms can be fed just enough to increase rapidly so that by autumn there will again be enough to eat all your winter garbage. Garbage can composting. Here's a large capacity vermicomposting system for vegetable-eatarians and big families. It might even have sufficient digestive capacity for serious juice makers. You'll need 2 or 3 20 to 30 gallon garbage cans, metal or plastic. In 2 of them, drill numerous half-inch diameter holes from bottom to top and in the lid as well. The third can is used as a tidy way to hold extra dry bedding. Begin the process with about 10 inches of moist bedding material and worms on the bottom of the first can. Add garbage on top without mixing it in, and occasionally sprinkle a thin layer of fresh bedding. Eventually, the first can will be full, though it will digest hundreds of gallons of garbage before that happens. When finally full, the bulk of its contents will be finished worm casts and will contain few if any worms. Most of the remaining activity will be on the surface, where there is fresh food and more air. Filling the first can may take 6 months to a year. Then start the second can by transferring the top few inches of the first, which contains most of the worms, into a few inches of fresh bedding on the bottom of the second can. I'd wait another month for the worms left in the initial can to finish digesting all the remaining garbage. Then you have 25 to 30 gallons of worm casts ready to be used as compost. Painting the inside of metal cans with ordinary enamel when they have been emptied will greatly extend their life. Really high-volume kitchens might run 2 vermicomposting garbage cans at once. End of chapter 6.